Good afternoon. All right, today we're going to continue talking about limits. We're going to be talking about limits as x approaches positive or negative infinity for what's called rational functions. Rational functions is where we have variables in the numerator and denominator. Now, we're going to be using these generic version of these in red here. They're not really all that useful, except they do give us a couple of pieces of information from our formulas down below. What we're looking at here is our p of x has a leading coefficient of ax to the n. Now, this is assuming that you're in standard form. Now, that n would be called the degree of the polynomial. That's the highest exponent for all terms in the polynomial. So that's why it's first. That's why I said it has to be in standard form. Then a would be its coefficient. Then for the second function, the denominator, we're going to use some different lettering. We'll use m as the degree or highest exponent for the polynomial. Should be listed first if it's in standard form. And then the b there would be the coefficient for that first term. All right, so here's how it works. If n, the numerator the degree from the numerator, is smaller than m, which is the degree from the denominator, then the limit of our function of f of x as x approaches positive or negative infinity equals 0. Essentially, we get a horizontal asymptote at the x-axis, or at y equals 0. You can see a picture there what that looks like, where you'd be approaching the x-axis on the left and the right. Then the second option is n equals m, so if our exponents are equal to each other, then the limit as we approach infinity to the left and right would be this fraction, a over b, and that's where we need those coefficients, the a coefficient and the b coefficient from those two terms at the beginning. And all that does is it just takes the graph I just showed you and just shifts it up or down by moving the horizontal asymptote off the x-axis. Then our third possibility is if the numerator has a larger power than the denominator, then the limit as x approaches infinity could be either infinity or negative infinity, and it just depends. There's more versions than just this one I drew here. There could also be a couple other options. We could have one like a parabola that's pointing down in both directions, or a parabola the other direction where it's both pointing up. We could have one going down, one going up. Again, that just depends on some other factors that we aren't concerned about today. All right, today we're just looking at whether or not we have a horizontal asymptote or if we don't. All right, so your answers will either be y equals 0, like right here, or your answer will be y equals some number, maybe a whole number, maybe a fraction, depends on how they work, or positive or negative infinity. We're not going to take that next step and figure out which one right now. Down the road we might take a look at that, but that was a pre-calc topic. All right, so let's look at some examples. All right, so this one here says identify the end behavior by identifying the horizontal asymptote. And this is what your assignment will look like today. So what we really want to focus here is on these leading terms, but we want to first make sure that they're in standard form. And it looks like they are. The largest exponent for the numerator and the denominator are listed first. All right, so then we want to take a look at which one's bigger. And in this case, n is less than m. The numerator is less than the denominator. So that would be situation 1 here. That means that we're going to have a horizontal asymptote at y equals to 0. So there's our answer. We're going to have the limit as x approaches positive or negative infinity of this function is going to be 0. Again, that's the same thing as saying the x-axis, or y equals 0. All right, next one. Again, we want to look at those initial terms, but we can double check and make sure they are in standard form, and yes, they are. I did put them in standard form. There might be one on the worksheet that's not. Maybe a hint there at you. Probably the last one, I would guess. All right, so let's take a look. So this time the numerator exponent is equal to the denominator exponent. So let's go back and look. If they're equal, then I have to find a horizontal asymptote at y equals a over b, right there in green. So a over b. So in this case, that means my limit as x approaches plus or minus infinity for this function, f of x, is equal to a, which is 6, over b, which was negative 2. Again, we're not in third grade anymore, so we always reduce our fractions. That one reduces down to the whole number negative 3. And that's the answer. We're done. Again, if you're curious what that would look like on a graph, that would be down here at -3. There's a horizontal asymptote, and the graph is somehow, approaching that line. All right, last one. Again, we want to take a look at our terms, make sure they're in order, and yes, they are. Again, maybe there's one on the worksheet that isn't. So in this case, our numerator is greater than our denominator exponent. So if we went back and looked, that means this third situation, where we have a limit that's either infinity or negative infinity. And again, in a later time, if we have a chance, we'll take a look at why, or which one of those it would be. So again, for this one, our limit as x approaches plus or minus infinity for this function, f of x, would equal infinity or negative infinity. Essentially, there is no horizontal asymptote in this particular picture. And again, the graph could be doing all kinds of quirky things, but at the end, it's heading up or it's heading down. It's not, blending into a flat line horizontal asymptote. And again, we'll worry about whether or not it's going up or down at a later time. All right, hope this makes some sense. Good luck today.